Hello and welcome to this lecture on integral calculus. In this video, we will see about changing the order of integration in single region. So I have listed the steps to evaluate a double integral which comes under the change the order of integration. First thing, we want to draw a region by using the given limits. So we want to take out the given limits of x and y which we have to draw a region. Then second step, we want to change the order of integration. If they have given dy dx, then we will change into dx dy. Then we will choose the strip as horizontal. If they have given dx dy, we will change into dx dy. Then we have to choose the vertical strip. After doing this, we want to find the new limits for both x and y. Then with the new limits, we have to evaluate the given function. That's all. So let's go for the problem. So here they have given a function. Integrate function will be x by x square plus y square. Here they have given us dx dy and they asked to change the order of integration, and hence we want to evaluate this. So here first see the limits of x. It varies from y to a, and limit of y, it varies from 0 to a. Okay, no issues. It is given in the correct form. We may go for the evaluation. So here the limit of x varies from y to a. So x is varying from y to a, and y is varied from 0 to a. So y varies from 0 to a is the given limit, that we call it as original limit, and x varies from y to a. So x. So with this we want to draw a graph. That means simply we know that y equal to 0, it will be of x axis, and x equal to y, it will be a line from the first quadrant to the third quadrant, and x equal to a, it will be a vertical line in somewhere in the first quadrant, and y equal to a, it also lies on the first and second quadrant, it is a horizontal line. So with this we will draw a graph. So I am drawing a graph. So this will be the x-axis, x-axis, here it will be y-axis. Then I may choose a line. So here y varies from 0 to a, x varies from y to a. So I may take this y equal to 0, it represents the x-axis. So this will be y equal to 0, and then we go for y equal to a. Somewhere else I may choose here. As y equal to a. So y varies from 0 to a. So next we go for x equal to y, so simply we know that x equal to y will be like this. So this will be the graph for x equal to y, and we have to go for x equal to a. So x equal to a, I may fix somewhere else here, because x equal to y means then the line y equal to a which crosses here. So this this will be a graph. This will be the graph for x equal to a. So x equal to a. So here the line will be, the region will be like this. So therefore this is the overlapped area. So within this region we want to evaluate the given function with respect to the variable x and y. This will be the clear version of the graph. Here this is the line x equal to y, here it is x equal to a, and here it is y equal to a, and here it is y equal to 0. So with the four equations we have plotted a graph, and this will be the common region. Okay, so if you refer the given problem, they have given us dx dy. If you refer the given problem, they have given us dx dy. So here we, after changing, it will become dy dx. Dy dx means we have to choose a vertical strip. We have to choose a vertical strip. So the given problem is a horizontal strip. After changing, it becomes a vertical. So let's draw a strip. Let me take some other line. So this will be the final strip. So after choosing the strip, we want to find the limits for x and y. So the strip is parallel to y axis. So first we want to find the limits for y. We want to find the limits for y. So the new limits, it will be y. So how do you choose the limit of y? First, if it is vertical strip, we have to go from the down to up. So first we have to choose the lower area, lower part of the strip. The lower part of the strip is attached to the equation y equal to 0. So the lower limit of y will be 0. And what about the upper limit? The upper part of the strip is joined to the equation x equal to y. So the upper limit of y becomes x. Then we want to find the new limits for x. So this is our common region. This is our common region. So here x varies from 0 to a because we have equation x equal to a. Here this point will be of 0, so x will be a 0. So from 0 to a, x varies from 0 to a. So lower limit will be 0 and upper limit will be a. So that's all. Now the given problem is in the form of dy dx. So I will write the problem here: 0 to a, y to a, and x by x square plus y square dx dy. This is the given problem. So if you see here, it is of dx dy. So we have changed it into dx dy dx. So it is a vertical strip. So the new limits, as I said previously, x varies from 0 to a, x varies from 0 to a, and y varies from 0 to x. So x 0 to a, 0 to x, 0 to a, 0 to x. So with this, I am getting a new integral. The older given problem will be 0 to a, 0 y to a, x by x square plus y square dx dy. So this is the given function. After changing, it becomes the same: x by x square plus y square. The integrate function is same. Now we have changed the order accordingly. The limits are also changed. The y limit is from 0 to x and x limit is from 0 to a. Then we want to do a usual procedure. We want to evaluate the double integral part. So let's start with the usual thing. First, we will take, with respect to, in if I take this function, first we have to evaluate the inner integral part with respect to y. So then x will be a constant. So I may take the x value over the integral from the outside over the integral. So I may keep a function 1 by x square plus y square. So and also we know that integral of 1 by x square plus y square dy will be 1 by x and tan inverse of y by x. So since we can use this formula, of course it has a limit 0 to x, so 0 to x, and we may substitute the limits as 0 to x. If I substitute the limit, I will get the value as tan inverse of x by x, it becomes 1, and 0, tan inverse of 0. We know that tan inverse of 1 will become pi by 4, will be pi by 4, and tan inverse of 0 will be 0. So if I substitute over here, I will get the answer as pi by 4x. Let's see the solution. I'm getting the value pi by 4x. So now we have evaluated the whole thing as pi by 4x. Now if I substitute over here, what will happen? It will be x into pi by 4x. X will be get cancelled, then pi by 4 will be there, and this will remain a constant. So I may take outside the integral simply x. And integration differentiation will be get cancelled. Then at last the solution will be pi a by 4. So therefore this will be the final answer for this double integral by changing the order of integration. So we go for the next problem. Here, if you see the previous problem, the same thing I have given. but the given problem which has the limit of y varies from y to a. So y equal to y equal to a. The lower limit is y and upper limit is a. How it is possible? So the given problem is in the incorrect form. So what we want to do, we want to change this given problem into a correct form. Then you have to take this as the given problem. Then now the limit of x will be y to a. How I change this? Simply I have interchanged this both, but I have not changed anything regarding the limit. I am changing the order alone, dy dx. I am changing into dx dy because this is in the incorrect form. So to make it in the correct way, I am changing the dx dy. So now the limit of x varies from y to a. So it is accepted, and y varies from 0 to a. So now it is in the correct form. Now we have to take this as a given problem, and the limit of x will be from y to a, and limit of y is from 0 to a. So similar to the previous problem, you will proceed with the procedure, and you will get the same answer what I did previously, the same problem. You will get pi a by 4. And you may take this problem as an exercise, a similar problem. We have to change the order of integration and hence you have to evaluate it. I have given the final answer as 1 by 2.